motion. All right, so got your calculator out. So we're going to have some fun here in the beginning. So we're going to do circles in parametric mode. Okay, and you know all how to change your calculator to parametric mode. You go to mode and you type in, or you scroll down and you get off of FUN or function and go to PAR, P-A-R, for parametric. All right, everybody got that? So let's graph in parametric mode. X equals 3 sine of t and y equals 3 cosine of t. All right, so on your calculator, I'm going to be in parametric mode. I'm already in parametric mode, so you go to y equals, and I'm going to clear this out, and we're going to type in 3 sine of t, and then 3 cosine of t. All right, now, I would like us, all the way around is how many degrees, or in radians is how many? 2 pi. So let's go to our window and go from 0 to 2 pi. So you type in 0 and then 2, pi. And you should get 6.28 something. Is that what you get when you type that in? Yep. And let's change our x min and x max, because I know this is a circle of radius 3. Let's make this -5 to 5 in the x direction. And we'll make it in increments of 1 so we can see that. And then we'll go from -5 to 5 in the y direction. All right. And then let's do a drum roll. All right, and we're going to graph it, and we get, oh, a circle, but it looks like an ellipse. Why?
Because it's how the graph calculates.
Right, kind of a rectangular screen. So how do I fix that? You can do zoom.
Zoom square.
Zoom square, which is zoom number 5. Anybody notice where that started?
At the top.
That's at the top, yes. So everybody see that it's a circle of radius 3. And it started its motion here at the top. And which direction did it go after that? Clockwise. So it started there and went around that way. So this is my abbreviation for clockwise. Now, as you saw on your handout before lunch, you could get the same equation or same graph with different parametric equations. Did you notice that? You're getting the same equation, same circle, but different motion. So let's try another one. Let's say we have x equals, let's switch the cosine and the sine. 3 cosine of t and y equals 3 sine of t. Let's do that on the calculator. It's going to be still a circle of radius 3. Now what happens when you graph that? Let's go to y equals, and we'll get 3, and we'll put a cosine here and a sine here. And I'm going to hit graph. Ooh, where did it start?
On the x-axis.
On the x-axis, sure. So it started here. Whoop, I'll type the ink. Here, and then rotated how? Counterclockwise. So here it started at 0, 3, and here it started at 3, 0, but this one went counterclockwise. Interesting, right? All right, what about this equation, set of equations? We can say -3 cosine of t and y equals 3 sine of t. What have I done now? change the signs, right? Haha. I know. We'll go to y equals, and I'm going to go second insert here because I don't want to have to retype everything. What happens if you hit the second insert? You can put the negative right in front. How nice is that? It is second insert. You don't have to retype everything. It's great. All right, so now I'm going to hit graph, and let's pay attention to where it starts. Ooh, where did it start? No, on the left side, on the left vertex. Oop, yep. So it started on the left vertex and went clockwise. So what is Parametrics doing for us? It's graphing a circle, but it's showing the motion starting in different places, which I think is pretty cool. All right, let's do another one. What should we do here with the negative? Flip them. So we'll say this is x equals 3 cosine of t. Y equals negative 3 sine of t. Now, where do you think it might start? Okay. So let's see if you're right. So we go back here to y equals, and I'm going to get rid of the negative here and do what to get second insert, the negative? Are we paying attention? Ooh, did it start at the bottom? It started on the on the x-axis on the right side and went down. So this would be counterclockwise. No, that's clockwise, isn't it? Sorry. So what are we thinking? Should we make them both negative?
Yeah.
Make them both negative. So let's say x equals negative 3 cosine of t, y equals negative 3 sine of t. So what happens? So it started on the left side and went counterclockwise. Still a circle. But let's try to think of some analysis here. These are all cosines in the x spot, correct?
Yes.
Except for the very first one. Now, where did they all start, the cosines? On the x-axis. Interesting, right? So when did we start on the left side? When it was negative cosine. When did we start on the right side? Positive cosine. Interesting. All right. So let's do all sorts of changing the signs here. This one here, the sign is with the x component. So this one starts on the y-axis. So what do you suppose is going to happen if I make this first one next? Start on the bottom, and then maybe we can start making a prediction as to which direction it'll go. But are we starting to see why it might start on the right side versus the left side? All right, so let's say this is x equals negative 3 sine of t, y equals 3 cosine of t. It requires me to do a little bit more changing here. So we're going to leave this negative, but we're going to change this to sine, and we're going to change this one to positive and make that a cosine. And let's see what happens. It started top. And it went what direction? Counterclockwise. what could I do? I could say x equals positive 3 sine t, and then y equals negative 3 cosine t. We'll make this positive, and second insert the negative. That one started. The bottom, and where did it go? It went this way, didn't it? So interestingly enough, what's happening here? It starts on the top when the y is positive, but it starts at the bottom when the y is interesting. And then the last iteration of this would be they're both negative. Oops. Anybody got a prediction? It's going to start at the bottom and go clockwise. Let's see. Second, insert a negative. Ah, you were right. So it starts at the bottom and went this way. So I think we did every combination, right, that we could? How many possibilities were there? Count them. 8. So if I got a quiz or a test, I could ask you to come up with a set of parametric equations starting at the left vertex with a circle of radius 5. Rotating counterclockwise. That's a lot of information, isn't it? What do you do? That's a lot of guessing, isn't it? Yeah. Now, first of all, why are these all circles? I guess that would be the first interesting thing to do. Yep.
Coefficients.
They're all, the coefficients are all, well, the absolute value of them are all the same, right? And they're all circle of radius 3. So if the coefficient was 5, they would all be circles of radius 5 if these were the same. Okay, so let's figure out why mathematically this works. Let's choose one of the 8. Which would you like to choose? This one, since it's right here? All right, so let's eliminate the parameter. On number 8 here. Okay, so let's do that. Well, how do we do that? First things first is we have to isolate the sine of t and the cosine of t. So let's do that. So that means we're going to get x over negative 3 equals sine of t. And then y over negative 3 equals cosine of t. And then we're going to harken back to our knowledge of the unit circle Pythagorean identity, the big ones, and square both sides of these. And why is that favorable to us when we add these together? Because that's an identity, and we can say sine squared plus cosine squared is equal to 1, and the t is now gone. And so we can we set this, now this is x squared over 9 plus y squared over 9 equals 1. And this is a circle of radius 3. But we don't see the motion. Why? What happened to the negatives and the positives? We got them squared. We squared them away, didn't we? So we can, this one is the rectangular equation, and it does not show motion. The parametrics show us the motion, right? And what was our window here? We went from 0 to 2 pi. Why did we do that, do you suppose? Why do you suppose I chose that?
Yeah, circle, full circle.
It's a full circle, yeah. Okay, so if I wanted to go around twice, right, you change T max to 4 pi. Okay, so let's stretch ourselves a little bit here and write an equation for an ellipse centered at 0, 0. And I don't care what the stretch factors are. You notice our circle here is centered at 0, 0, correct? And we want to write this parametrically. Now, an ellipse is similar to a circle, except what? It's got a horizontal stretch factor and a vertical stretch factor that are different. So can somebody give me a suggestion for an x and a y? Now we use 3 cosine and 3 sine, but those, yeah, Gareth?
So like 3 sine and 5 cosine.
Okay, sure. Well, so 3 sine of t and 5 cosine of t. I like it. So let's see if it works. Where are we going to do that then? Go to our parametric mode in our calculator again, and we're going to say, I already got 3 sine t in here. The only thing, oh, I don't want to make it negative because we're going to be positive while we're doing this. So I'm going to delete this and put a 5. And do you think 0 to 2 pi is going to work?
Yes.
Yeah, I think so too. So let's graph it and see what we get. We got an ellipse, didn't we? Nobody's really super jazzed about that?
I'm jazzed.
Why does your calculator graph it so fast?
Because I have an Intel processor,
She's got all the gadgets.
right? Well, I'm doing it on a computer, right? And the processor on your calculator is a little bit slower. I'm sorry.
A little bit.
A lot, okay, a little bit, a lot. Do you know what I'm saying? Yeah, I'm using a computer processor versus the calculator processor. I'm so sorry. Is the 89 graphing faster?
Yes.
Yes. Just gonna throw that out there. Not that I work for TI or anything, because I don't.
You probably should.
All right, so what do we notice here? This is indeed an ellipse, centered at 0, 0. Notice anything? What's the stretch factor in the x direction? 3. Where is that living? It's the coefficient of the x. What's the stretch factor in the y direction? 5, and that is the coefficient of the y. Very good. Now, where did this start? I missed where it started. It started at the top, and it went clockwise. Nice. What if I wanted it centered somewhere else?
Plus
Hmm?
1. 3 sine t plus 1.
Okay, let's try that. I like that. So let's say we say x equals 3 sine t plus 1, and then y equals 5 cosine t. We'll just leave it. We'll just change the x. Let's see what happens. Now I'm going to put this in a second parametric, which is underneath it, so I can see it, and mine will be a different color when I draw it. Okay, so what are we going to do? We're going to say 3 sine of t, close parentheses, plus 1. Hop down and then say 5 cosine of t. And let's see what happens. Oh, where's it centered?
1 to the right.
At 1, 0. It went to the right. 1. Nice. So this is the red curve, centered at 1, 0. So how would I put that in rectangular form? We're going to eliminate the parameter again. What are we going to do? We're going to solve for sine of t and cosine of t. Now, why on earth am I doing that again? Because when you get a loan, you square it. Yes, and something wonderful happens. That's right. That's right. So let's get them alone. So we're going to say this is x minus over 3 equals sine of t. God bless you. And this would be y over 5 equals cosine of t. And then we're going to square both sides. And when we do that, and we add them together, these equations, we're going to get x minus 1 quantity squared over 9 plus y squared over 25 equals 1, which is what we're familiar with, the ellipse equation in graphing, standard graphing form that we understand. And do you see how it's centered now at 1, 0? So what would the generic be? A circle. So I could say x equals, what goes in front? Go back. What goes in front? What is this called? This is the radius, isn't it? So generically, I could say this was the radius times cosine of t, or x equals the radius times some sine of t, and then y would equal the, just remember this is for a circle, so r sine of t, and then y would be equal r cosine of t here. And you can have, this could be plus or minus based on where you wanted to start, right? So this would be the parametric equations for a circle, generically. What about the generic for an ellipse? I can't spell. We knew that. We would say x equals plus or minus a cosine theta. Y equals then plus or minus b sine theta. Or sine t, right? I'm sorry, sine t. Now this would be, both of these are centered at 0, aren't they? So how would I get them not centered at 0? Let me do that. You go plus h plus k plus h plus k, and that would be centered at hk. And this would be plus h plus k. What kind of an ellipse would this be? A football or an egg? Remember what the ellipse is?
Football.
It's a football because A has to be the bigger quantity. So this would be a football ellipse. Centered at, and I'm just going to put a football ellipse here, centered at HK. That's the center. What about, and this could be sine or cosine. What about for an egg shape? Plus or minus B cosine of t. Y equals plus or minus A sine of t. And then I could add a center if I wanted. Does that make sense to everybody? All right, so let's do an example here where we want to do a circle centered at 0, 0 with a radius of 4 starting, I'm going to give you a starting point now, at left vertex. Now left vertex means on the x-axis, on the left side, and we want to go clockwise. All right, so we're going to come up with some set of equations here, parametrically. So if you go back to your first page, let's think about it. We need something that starts on the left vertex. Which one of ours started on the left vertex? But you only started on the left vertex when it was a cosine in the x spot, didn't you? Left or right? So we know, what is it going to be without this, not worrying about the motion yet. We know it's going to be a 4 cosine of t. And then we know it's going to be a 4 sine of t because they come in pairs. And since it's centered at the origin, I know that there's a plus 0 and a plus 0. Now, if you go back to the front page, if you were a betting person, you would suggest that it has to,
Negative.
you're going to have the negative up here. Now, that's a lot to memorize, but let's see if we're right. What happens here? If we go to our graph on our calculator, y equals, and I'm going to clear, 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 clear. And we're going to go up here, and then we're going to put in negative 4 cosine of t, and then 4 sine of t. Let's see if we're right. Are we? Everybody watched what happened? That's good. Now that's going to, you wouldn't want to have to memorize all 8 versions of this, would you? No, right? So there's a little method here that I learned from someone to show me how to do this. Would we like to know that method?
Sure.
Okay, and this is the motion we want to do. Okay, so if you're centered at 0, 0, and if you're not centered at 0, 0, just in your mind, bring it back to the 0, 0. In the x's, if you want to start at the left vertex, what sign is the x over here? Negative. And then you move to what quadrant? Quadrant 1. And what is that sign? Positive. And then you move down to quadrant 3, which is Okay, so the x's, right? We're going to go from negative to positive to, the x is still positive in this quadrant, agreed? And then we're going to go to this quadrant, and the x's now are negative. Everybody got that? All right, so what are the y's going to be? They're going to start off positive, positive. So positive, positive, negative, negative. Now this is the way that I like to think about it. This is a cosine curve, correct? So in my mind, I think a cosine curve starts on or off the midline. Off. And so if it's negative, it's going to be like this. You see that? So that means I have to have what in the x spot? A negative cosine curve. And sine starts on the midline, so it's going to look like this. So what? This is a negative cosine curve. And this is a positive sine curve. Do you see that? So how did I come up with that? This would be quadrant 2. This is quadrant 1, because that's where the motion's going. This would be quadrant 4, and then this is quadrant 3. So I'm going from quadrant 2 to 1 to 4 to 3. And that's how I know that my this one has to be negative. You want to do another one?
Yes.
I knew you would. Okay. So you guys are going to help me with the equation then, because we're going to show that it's not dependent on just me. Shall we do an ellipse? Where would you like it to be centered?
1, 2.
Okay, centered at 1, 2. And you want it, now we have 4 places to start. We can start on the left or the right or the up and the down. You want, okay, at the bottom? And which direction would you like to go? And all right, so we need some stretch factors. Okay, so all right, so we want 5 and 2. So stretch factors of, whoops, God bless you. And we'll say the x stretch is going to be 5 and the y will be 2, okay? So the very first thing I think of is where are we starting? We're starting at the bottom, and I'm going to have an ellipse centered at 1, 2, but I'm not going to do that. And the x stretch is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we go. And then stretch is 2 in this direction. So it looks like this. It's a football. Correct? And we're starting where? At the bottom. So we're going to start down here. But I'm going to, in my mind, bring this back to the origin. If my motion starts down here, and we're going counterclockwise. Which way are we going? Counterclockwise is this way, right? So in the x direction, what do you think x is going to be? What sign are they here? Positive. The x's are, well, but it's, the x values here in this quadrant are positive, and then I'm going to move to the first quadrant where they're both positive, and then the x's are negative and then negative. You follow? And then the y's, if I start down here, are in this quadrant what? Negative, positive, positive, negative. So let's, in our mind, what kind of curve is this? This is a positive sine curve, and this is a negative cosine curve. So coming up with the parametric equations, I'm going to say x equals, well, I need a positive. So it'll be 5 sine of t plus 1. Good, for my center. And then y will be negative 2 cosine of t plus 2. Yes, so let's see if it works. See, I like this because it doesn't require much having to think back of those 8 possibilities, right? That helps me a lot. All right, so let's clear this out and type in our 5 sine of t plus 1, and then negative 2 cosine of t plus 2. Now I'm going to change my window a little bit because I think I'm going to extend beyond the window I have. So let's just make this negative, what should I do? Negative 8 to 8. And then let's hit graph. Did that work? Did it start at the bottom and then go counterclockwise?
Yes.
How cool is that? So could you set up any one you wanted?
Yes.
Yep.
You could. So think about it. Could you start from the very beginning? Like if I gave you x squared plus 4y squared plus 2x minus 24y plus 33 equals 0. And I said I wanted you to come up with a set of parametric equations, starting at the top vertex and rotating counterclockwise. So let's think about that. What is this? It's, well, okay, so if I looking at the equation, can you tell me whether it's a circle or an ellipse?
It's an ellipse.
It's an ellipse because the A and the B or A and the C are different numbers. You're right. So we have to complete the square twice. So x squared plus 2x plus something. What's the plus something? 1. Plus, I'm going to factor the 4 out, and I get y squared minus 6y plus 9 equals negative 33. And then I have to do what? I have to add 1 and add 36. Good. So we get x minus or plus 1 quantity squared plus 4 times y minus 3 quantity squared equals 4. Yep, so we get quantity squared over 4 plus y minus 3 equals 1. Now I'm going to put over 1 here because it'll help me with the coming up with the equations. So x equals y equals. Do we know what the stretch factors are already? We know this is going to be 2 and this is going to be a 1. But I want to start at the top vertex. And I'm just going to draw a random ellipse at the right. And we want to rotate counterclockwise, which means this way, right? So if I'm starting up here and I'm going this direction, what are the x's telling me? Negative, negative, positive, positive. Good. Y equals, what are the y's telling me? Positive, negative, negative, positive. If you were going to superimpose a graph on here, this is a negative sine wave and a positive cosine. Are you seeing that in those numbers? So this is going to be negative 2 sine of t plus or minus 1, because it's centered at -1, 3. And this would be cosine t plus 3. All right, so have a good rest after afternoon.